So okay guys, let's I'll basically will be repeating back what I've discussed with the group 2 just now. We are going through one example here. One question from one of the final exam question. I forgot which year was it. Right. In this case, we are basically solving for velocity and acceleration. Okay. Tak nampak lah. Okay. Velocity and acceleration. Okay. And now the case here is that we see it is a crank slider problem. And okay, but before that, remember that you don't have ample time like what I'm having now. Okay, you have a very limited time. So whenever you are presented with a question in your final exam, immediately you need to recognize the important parts. Okay. So in this case, it's a power saw. This is the power saw driven by electric motor as shown in figure Q1. The 75mm crank, so this is the crank, turns clockwise at the speed of 40 rpm and acceleration of 40 radian per second square. The distance between the joint BC is 180 mm and has an offset of distance AC equals to 90 mm. So this is the offset between the sliding axis and also the rotation axis A. So first of all, we need to, maybe the easiest is to basically find the omega 1. Okay, so given 40 rpm, I already done the calculation here based on the previous group. Omega 1 equals to 40 times 2 pi over 60, so it is 4.19 radian per second. Okay. So the first step now, we need to draw the kinematic diagram. Well, we have to draw the kinematic diagram before we can basically solve the other things. Reason is because we need to know the angles. Okay. For example, for all the velocities here, we need to find the angles, especially in this case, the VCB, right? And later on for acceleration, we need to know the ACBN, right? That's the angle. Huh? You can't see it? Oh, okay. This is basically VCB, ACBN. Okay. All right. So first we have to draw the kinematic diagram. So we need to know the appropriate scale. So this is, since it's 75, 180. If you want to use 180, the whole part is gonna be quite long, right? Which is equals to 18 cm, right? And 75, 7.5, it's gonna take a lot. So let's say if you just want to use one graph paper to solve it, so you can basically divide by 2, top and bottom. So you need to use an appropriate scale to be able to fulfill this. So let's say here is 75. What kind of scale can you use? Scale basically 1 mm to 2 mm on real lah kan. Tak apalah ni, we understand lah this one kan. So 75, it will become what? 3.375 kan? 37.5. 37.5 become this long lah. So it will be somewhere here. So we can basically select a point somewhere here maybe. Or maybe here pun tak apa. Here. Alright. Let's say we select point here. And this crank is at 30 degrees. So we need to draw a 30 degrees line. In my case, I'm having a very big protector. Kan? So if you have a small protector, it will be easier actually. Kan? So, but since I like to have big, so in this case I cannot make a mark here. So I need to have the opposite way, opposite direction. So let's So in this case, this is you have to do this direction 30 and then which is AB equals to 37.5. Okay, it is 30 degrees. This is 4. So 35, 36, 37. Okay, this is 37. Actually, my eyes start to be a little bit, what do you say, blur now. I think maybe due to age, aging factor. So this is A, B. Then to draw BC, you need to have it on the line here, right, on the vertical sliding, the horizontal sliding part. So it is basically offset of 90 mm. Sorry, 90 mm. So we have to measure 90 divided by 2, so 45, right? So 45 will be somewhere 45. So just draw a straight line here. Now we have to draw the link BC. So we have to use the compass now. So BC is 180, so it's equals to 90, right? Divide by 2 is 90. Okay, so this is the angle. This is the point of C. Alright, so this is C. So crank AB is basically rotating clockwise direction. Alright, with the radius, with the angular speed of 4.19 radian per second. Then we need to calculate the VB. What is VB? So VB is equals to omega R, omega 1 RAB equals to what's that? 4.19 times 75 equals to, I have the answer but I want you to calculate. What is the answer? Huh? Nampak? Clumsy betul lah. 314.25 5 millimeter per second. Now, so VB is in this direction. Sorry. So VB is perpendicular to this. This is VB. Alamak. No let. Yeah, okay. Ada. Ada. I managed to have a single lead here. So this is VB. Now we do not know what is the value of VCB and VC. But of course, VCB will be in this direction. It's best if you have the right angle triangle. So now we do not know the direction, which one, to the top or to the bottom. But now we need to find the angle. So let's say we extend a little bit, so it'll be easier for us to find the angle. Okay, what is the angle here? The angle here is basically 60. Wait. This is 69. So the angle here is 69 degrees. Alright. So here is of course 69 degrees. And here is, what will be the angle here? 90 minus 69? 21 degrees. Alright. Just now I measured it wrong. With your other group, I measured it 73 degrees. You want to know why? Because when I look here, I counted 70, 71, 73, something like that. So you are the correct one, basically from 0, 60 and then 69, you know. So fortunately I recorded this one. So it's very important that you know the direction of the angle. Just now I was a bit confused, but doesn't matter. Fortunately, I'm not the one answering the exam question. Alright, so it's 69. So it's going to be VCB here, either of the direction. So before you want to draw the velocity diagram, it's important that you know roughly what is the shape of that. Okay. Here, in this case, what is the angle? So VB, you need to know what is the angle here. What is the angle? So this is 30, right? So this is 30. That means here it should be 60 degrees. So here 60 degrees. Okay. Tak apa clear kan? Maybe because the cam is very low quality one Logitech. Next time I have to buy a bigger camera. Anyway, so we know that it's gonna be roughly this way. This is VB and this VC. You know VC will be in this direction because since AB will be rotating clockwise, it will pull the C to the right, right? Okay, so that means VCB will be in this direction, the top one. Yeah. So this will be CB. So when you draw this, once you know that it will start from the top left, so you can basically start drawing here. If not, you might start somewhere in the middle and then you don't have enough space to draw. So it's quite important that you actually draw first how it will look like. So we can draw from the bottom part. Now this is 314.25 millimeter per second. So are we going to use the full length or we don't have enough? This is 30. So we need to rescale it also. So what kind of scale should we use? So what is the scale? 1 millimeter to, well, how much you want to divide? If we divide by 2, is it okay? Divide by 2. 314 divided by 2 is equals to 150, 157. Yeah, confirm? So 157, it will be somewhere here. So we need to select maybe a point here. Get the 60 degrees. Okay, get the 60 degrees. Get the 60 degrees here. then measure 157. 15. Oh, sorry, you cannot see. Itu. So 1, 5, 5, 6, 7. Okay, it will be up here. Then we need to draw the VC line, which is simply horizontal. Okay. Then we need to get the angle, which is here 69 degrees. Okay. So you have to measure 69 degrees from here. 69 will be somewhere here. So this is basically VCB, because this VB and this VC. So we need to measure now. This will be the line, the point. Oops. It's equals to 145. It's about 145. Equals to 145 millimeter times 2 is equals to 290 millimeter per second. So VC is equals to siapa? Prof Miam. Tak dengar, tak faham. VC is equals to Prof Miam. Alah kau ni, aduh. So this is 129, kan? This is about 129. So VC equals to 129 millimeter times 2. 1? 258, ya. Tu yang malas nak rekod ni, banyak bloopers ni. 258 millimeter per second. Okay, so we have already the value. VC equals to 258 millimeter per second and VCB equals to 90 millimeter per second. So dapat dah. So we have answered the first part. Now the second part is the magnitude of acceleration of the blade. So to do that, we need to calculate the acceleration now. Okay, to calculate the acceleration, we know that AC equals to AB plus ACB. And so AC, there's no more component, only AC. Right? So AC equals to ABN plus ABT plus ACBN plus ACBT. Then we need to calculate the ABN. ABN is equals to apa dia? Omega 1 square R AB. So this is equals to 4.19 square apa? 75 equals to kira cepat. Kira, jangan tak kira. 1316 tu je. 0.7 millimeter per second square. Then we have this ABT equals to alpha 1 RAB equals to 40. In this case is 40. 40 times 75 equals to 3000 millimeter per second square. Then we have ACBN, which is equals to omega 2 square RBC, RCB, whatever lah. So omega 2 equals to So we already have the VCB, 290. So omega 2 is equals to 290 divided by RBC equals to 290 divided by 180 equals to 1.61 radian per second. Okay, 1.61. So in this case equals to 1.61 square 180 kan? Equals to what? 46.5 millimeter per second square. ACBT kita tahu? Kita tak tahu lah. We need to do the drawing lah now. Now we need to do the drawing for acceleration. Okay, before we do that, we have to know the angle also. So ABN will be in this direction. ABN. So ABT will be in this direction. So ABN is equals to 30 degrees to horizontal. 30 degrees. Right. ABT 60 degrees. And ACBN in this direction. CBN 21 degrees. ACBT we don't know. It's going to be like 69. All right. So with 69 degrees. So as we have done in velocity vectors drawing, velocity plot, what we do now is also we need to sketch the approximate shape. So we can draw starting from ABN. Let's say we take this point 131 like this. Then we have 3000. 3000 is almost twice than this. 60 degrees. Yeah, almost twice. And then we have 400. 400 is about 1/3 of this. And we end at 21 degrees. So this is at 21 degrees, 1/3. And then we don't know what is CBT, but it's gonna be like 90 degrees here. Will be top or bottom, going towards that. But we know that AC will be horizontal, right? So in this case, we know that ACBT will be going in this direction. So to draw this now, we need to basically decide either we want to draw horizontal or vertical. In the previous group, I draw it horizontally. But of course, we need to have a proper scale. What is the appropriate scale for this one? We have 131, 3000 kan? 3000 divide by berapa? 3000 jauh ni kan? Tak boleh, tak cukup. So divide by how much? The previous group suggested divide by 100. Divide by 100, it become 30 mm is equal to 3 cm kan? Banyak ni je. Oh, jimat kertas katanya. Divide by 50. So we got 15 here. That is more appropriate. Hebat. So to make us not too confused, maybe we can straight away divide here. So in this case, ABN is equals to 1316.7 divided by 20. How much? 1316.7 divided by 20. By 50 divide by 50 sana. 50 or 50. Divide by 50 become what? By 50 gonna be too small lah. Still very small. 3000 divided by 50. 60. 6 cm je. Ayalah. No. What I did was basically divide by 20. Divide by 20. No 50. So 1316.7 divided by 20 will become 65.8 millimeter. So this is ABN. ABT is equals to 3000 divided by 20 equals to 150 mm. ACBN equals to 466.5 divided by 20. Apa? 466.5 divided by 20 equals to 23.3 mm. Now, once we got all this, then we can start drawing it. We can, let's say we select the top of this. So this will be the 0. Then we want to draw ABN at 30 degrees to be 65. Where's the compass? So 30 degrees. 30 degrees should be here. The line is 65, I mean 6.5 cm. Then should be at 60 degrees to horizontal, or you can basically just perpendicular. So this one at 150. So this is ABN, ABT. Then we need to draw the ACBN, which is at 23.3 at 21 degrees. Okay, since I don't have enough space for I can. So 21 degrees is somewhere here. For the length of 23. So this 23. Then we draw the 90 degrees to this for the ACBT. So with this we got this ACBN, ACBT, AC. So to measure, to know the magnitude of AC, we just measure this. It is basically 105, about this. 105 mm. So AC is equals to 105 times 20 equals to 5 times 20, 2100 millimeter per second square. Done. So we already have the answer for the acceleration of C. So usually depend on the mechanism, you're gonna be given a load or weight or whatever. and once you know the acceleration, you can basically start to solve for the forces. Right. So we're going to do the force examples tomorrow. Okay. So now it's 40 minutes involving all this talking here and there, right? If you concentrate with your exam, you're going to take less than that. You know that? But it's very simple, what?
Yeah, but it's very lengthy.
That's why I told the other group. This question will take maybe about 40 minutes to 1 hour. But there are other questions which is much simpler. For example, maybe gears. Yeah? Gears are much simpler. Betul tak? So you need to basically strategize. Once you receive your question papers, do not immediately answer the first question. For example, if the first question involves a problem like this, then you might need to skip first to answer different question, which involves a much simpler solution. Because definitely when you do with graphical, it will take time. And as you can see, I do not really stress on the accuracy. It's about, that's enough. Okay. You're not going to use micrometer ke vernier caliper ke, right, to solve this, right? You just need even my eyes are actually blur. At this line I cannot see already where's the line, because of the aging. But long distance I can see. Okay, I don't need to spec for long distance. That means I'm old lah kan. Old man is having the what? Rabun dekat kan. I thought I need to spec it, but then I cannot do anything. I'm old. Alright, so that's it.